Hi, this is a modified Mark II rig to show the effect on my energy measurements of the RFM12 chip being turned on. What I'm finding is that the action of sending out an RF message has quite an effect on my energy measurements. So on this particular box I've got a 20 bar display which shows the state of the energy bucket. At the moment we're sitting right down near the bottom. And I've got a second LED over on the right, and what that shows is it comes on for any main cycle when the energy state, the state of the energy bucket, is lower than it was on the previous time. So as there's no current being measured at my CT, there's my CT, it's going around two coils of a wire that's supplying a 40 watt light bulb, and as we're not on, roughly 50% of the cycles are lower than the previous one. Now if I were to switch the light on, like so, then we'll see the energy bucket increasing slowly, and we see no pulses at the indicator LED, because every main cycle you'd expect to be a couple of joules higher than the previous one. So we go all the way through from minimal energy state up to pretty well the top of the bucket, and only when we got to the top of the bucket, when limits cut in, might we expect to see the indicator cutting in. So nothing much of interest there. If I reset the system, turn my light off, we'll go back to where we started. We're in flickering. Now that run had the RF module disabled. I can switch it back on by a switch. This simply enables all the calls to the RF, which is any calls that relate to thresholds, and I'm in a normal mode. So if the energy bucket is above the halfway, I'll send a radio command to say turn the load on. If it's below halfway, I'll say turn it off. And I also have a 2-second refresh in there. So I've now got the RF enabled, and if we turn the light on just as before, I think we'll see something interesting happening. Every 2 seconds there's a pulse to show that I'm getting a perturbation of my sequence of energy measurements. Very, very prominent. Now when we get to the halfway point, which is in a few seconds, you'll see something else. There we are. What that actually was a sequence of a substantial number of flashes, because the act of turning the radio unit on was causing my energy levels to dip below the threshold. There's one threshold, there's actually two thresholds, but they're at the coincident level. So when you're in normal mode, with only a slow amount of power coming in, we're getting multiple switchings at the critical point. If I were to repeat that run, but this time go into an anti-flicker mode, here's anti-flicker mode. So the light is on, we're seeing perturbations to the sequence every 2 seconds, which is the refresh rate, and when we get to something over the halfway point, we will cross the upper threshold for anti-flicker. And all we get is one RF event, but we won't get the same fluttering effect, because even the amount of effect that the energy bucket is having as a result of sending an RF message doesn't take us into the other zone, which is below the lower threshold, which is several hundred joules away. So there we are. If I turn we're now up at the top, so we're sitting at 3600 joules if I leave the light on, but just turn the RF off, so there's no refresh messages. We're now sitting at 3600 every time solid, because each new measurement is a couple of joules, which gets reduced to 3600 by the maximum limiting function. 3600 joules is not less than 3600 joules, so we never see the flash. But when I put the radio on, every time there's a radio message, we're seeing some negative energy content in our energy cycle, so that's dropping the value below 3600, and it's being reliably picked up by my little detector. So quite a significant effect seems to be happening when the RFM12 is asked to do something. I've not yet been able to quantify the effect. It's a little bit more complicated to do that, but I'm most interested to know whether anybody else has seen this effect. If you're not using a radio chip to divert power, then obviously there'll be no possible degradation from this effect. So that's all for now. Cheers for now.